Welcome to the Control Engineering How to Automate series of webcasts. The first in the series is How Next Generation Automation Will Help in 2023, sponsored by Kepware, a PTC technology, and Ovacy MDT. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of the program will be reported to RCEP at rcep.net. A certificate of completion will be issued to each participant. As such, it does not include content that may be deemed or construed to an approval or endorsement by RCEP. This course will include system integrator discussions of next-generation automation technologies that can help implementations be more competitive. Also covered will be control engineering research about what automation technologies are expected to help with that. And audience members listening live will be asked for their input starting as the starting point for the discussion. The learning objectives for today's course are listed here. We're going to review the research about what technology topics are most useful, understand system integrators' views and advice, prioritize what to do first based on your pain points and business needs, and hear examples and best practices related to those technologies. To get the best results from the webcast platform, please note the following. If you have technical problems, click on the question mark at the top right-hand corner of the screen to bring up a list of system checks before escalating to an online technician. If you're experiencing issues with the slides or the audio, please refresh the browser or click the Refresh Media button directly under the presenter's headshot. You can control the volume settings of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Answers to your technical questions will be in the Answered Questions box on the left side of the screen. Use the Ask a Question box on the left side of the screen to type questions for any of the speakers during the presentation for the Q&A session at the end. You may ask questions at any time during the presentation, and we'll get to as many as time allows, with verbal answers during the Q&A at the end of the webcast. To download the presentation slides, use the Event Resources area on the left side of the screen. Expand the presentation screen size using the arrow in the upper right. To take the Learning Unit exam, use the Learning Unit exam tab option at the top of the screen. An exam will open in a new browser window. You can complete the exam after the webcast. However, that link will break when the webcast signs off, so if you're taking the exam, you might want to open that now. Exam also will be posted on the on-demand version of the webcast. The exam is for 1 RCEP ACEC Certified Professional Development Hour. The webcast is being recorded, including the Q&A session. We'll post the archive on the Control Engineering website in a few days and then send you an email with a link to the archive when it's ready. The method of delivery and category the event is a live educational webcast presented on January 18th, 2023, and the educational category is Technical, Health, and Safety. Now we'll pause here for a word from our sponsors, Kepware, PTC technology, and Ovacy MDT. Please stay tuned because after the video there will be a short pause to compensate for varying internet access speeds, and then we'll get right to it.
You're running a plant, an oil rig, a wind turbine, the production line, where information is needed to keep operations running smoothly. There's nothing worse than connectivity problems, including unreliable or inaccessible communications, different proprietary protocols, and multiple standards. The constant need to install, learn, and maintain new solutions. And of course, downtime. Because when downtime strikes, the work stops, and the work can't stop. Enter ThingWorx Kepware Server. It's a connectivity platform. You connect it to every PLC, RTU, flow computer, and automation gizmo that speak all those different complex languages. and watch as it collects the information you need to just one place and starts translating. ThingWorx Kepware Server. When things just work, work gets done. Download a free demo today and you'll be up and running in just 5 minutes.
I support an American online retailer to ensure that in the event of an emergency, machine settings can be restored at the press of a button.
I help world-renowned breweries avoid downtimes and, in doing so, help to increase the efficiency of their production environment.
I help an Italian confectionery company to ensure that even the smallest deviations to a product's taste can be immediately detected.
I help our plant engineering customer ensure that the data generated by their vendor-independent machinery is stored centrally.
Our software solution helps to reduce downtime and increase overall safety and security in production environments.
All right. Now I'm very pleased to introduce today's distinguished speakers. Each of these three firms is a Control Engineering and Plant Engineering System Integrator of the Year for 2023, so we're especially happy to have them represented in this webcast. Tyler Graham is a Director of Business Development of Digital Transformation, and Randy Roche is Director of Technology Digital Transformation, both with EOSIS. Tyler is responsible for continued growth of digital transformation practice and has more than 20 years of system integration experience and is passionate about helping customers leverage data to help solve manufacturing challenges. Randy, prior to EOSIS, led digital technology innovation at Cytiva and spent 18 years with GE focusing on digital transformations, Industrial Internet of Things, lean manufacturing, agile software development, IT/OT convergence, and controls technologies. Mike Howard is Vice President of System Integration, George T. Hall. He has more than 30 years of industry experience and heads the SI operations and mentors company business development engineers, project managers, technical teams and engineers, and product teams. Matt Luger, Executive Vice President with Northwind Technical Services, works with manufacturers in the food, beverage, plastics, and pet food industries to find automation solutions that increase plant efficiency. He has 15 years experience with controls and automation and a degree in electrical engineering from University of Kansas. I'm Mark Hosky with Control Engineering, covering automation, controls, and instrumentation since 1994. I have a Bachelor of Science in Journalism, and I've been writing and editing since 1982, and I've been writing about technology since 1987. Now we want to know a little bit more about you. So this is the same poll question that we ask subscribers to help guide Control Engineering's topical coverage in 2023. We want you, the audience members today, to indicate the most important topic category to help you in your job in the coming year. So go ahead and pick two, and then we'll review the results as we go. So we have control systems and related strategies. That would include controllers, edge and cloud computing, machine control, AI, ML, mobile devices, networking information, including I/O systems, HMI, SCADA, analytics, safety, cybersecurity, Industry 4.0, IIoT, networking and information, including I/O systems, HMI, SCADA, analytics, safety, cybersecurity, and then let's see, control equipment and energy, and then system integration and workforce development. So let's take a look at how the results are coming in. So here we go. We have, wow, a pretty equal mix, with the most in the control systems and related strategies area, running neck and neck with networking and information. So that's interesting. And then not far behind is system integration and workforce development. and then control equipment and energy. So now that we see that mix, let me just ask quickly our participants what they think that's a very even split. All right, so hearing none, no participants, we'll just go right on with the next part, and then we'll see how control engineering research compares to how the audience felt about those findings. So here we see the leading in topic in the control engineering coverage area, according to subscriber research conducted in July of last year. And 59% of the subscribers, the largest base, selected control systems and strategy as the most important area for the coming year. So among our system integrators represented, pick one or two perhaps of any of those categories under control systems and strategy that seem to be important for your customers. All right, I'm hearing none. So we're going to go on to the next question. I'll just run through the research, and then we'll ask our presenters to unmute and comment when I'm done with the results. So here, the second area for the control engineering subscribers was automation, networking, and information. And here we have some of the product areas underneath that area, but that was 34% of subscribers who had felt that things in those areas would be helpful to them in the coming year. And control equipment and energy, 46% of participants felt that they would find useful areas in that in the coming year. And then 43% automation industry, system integration, and workforce development. So as you can tell from the percentages, we allowed more than one entry as well for these results. But I found it especially heartening that system integration came out on top of this category. So any reflections before we start with the formal presentation on how that would compare to what you're seeing in the marketplace?
Yeah, thank you, Mark. This is Mike Howard. Yeah, I agree that, when you look at the automation industry, system integration being heavily favored, I think as technologies get more complex, people will need to reach out to those that have that expertise to help navigate, through those technologies.
Great. Any other comments about the general groupings and research?
This is Tyler from EOSIS. Just found it interesting, I guess, that the online polls seem to have a heavier weighting on the second item there, which I think was a lot of the networking industry 4.0. It wasn't as highly rated in the original poll. So we know who some of our audience is today on the call.
Yes, and we know that the parts of the control loop need things to connect them together. So networking is certainly a very important aspect. Good. All right, so let's go on. The next learning objective that we're going to address is looking at understanding system integrators' views and advice. And Randy is going to kick us off from EOSIS. So Randy, go ahead.
Thank you. You're tying all of those broad categories that we just looked at together. I want to take a minute to define digital transformation. Right? So it's not just digitization. It's not just paper glass. It's about leveraging a data-driven culture to make better business decisions faster. When you make your decisions based on data, when you have ready access to that relevant information, you can adapt to the realities of right now faster than your competition. Right? So the primary value of digital transformation is business agility. So when we talk, what kind of decisions are we talking about? Like, I'm not talking about a decision that a ladder logic or a flow chart could make. I'm not talking about a straightforward local optimization. I'm talking about analyzing your OEE trends to decide which CI project to implement. Talking about how do you troubleshoot the root cause of a nagging issue? How do you optimize your supply chain? How do you understand why some batches are good and some batches were bad? And how do you take field data back and part of that? How do you answer questions about making your business more competitive and understanding your customers? So answering these types of questions requires analytics at a higher level. You need to answer questions you didn't know you had when you first installed your equipment or built your traveler. If you're good at it, you resolve that issue and you move on to the next question, which oftentimes requires a new piece of information that you didn't have before. And if every time you need to answer a question, you have to kick off a systems integration project to go get a new piece of data, you're not going to answer very many questions, or at least you're not going to do it very quickly. Traditional manufacturing information systems are really good at what they're designed to do, but you can't just bolt analytics on top. Advanced analytics requires data to be in a form that's analyzable. The industry acronym is FAIR. You need findable, accessible, interoperable, reusable data. So if you don't have that data readily available in the right context, you're unlikely to get much out of it. So what can automation and control groups do to lay the foundation for analytics to help run your business better? Well, you can use modern standards, you can avoid data silos, and you can add context. So as your decision complexity increases, you'll likely need information from lots of different sources. There will be more and more consumers of that data. We won't be able to say how future analytics will utilize that data, and we'll need to know the context of that data so we can derive information and derive higher levels of meaning. So a great place to store all that information about the asset is with the asset. In this case, we could use an asset administration shell. So an asset administration shell, it's a digital twin of a physical asset that provides a standard way to describe and access information about an asset. So think about it as a container that holds information about that asset. So if you could tell you, say, the type of it, the location, the details, could tell you about references to other assets. And you can query that asset shell to figure out where it is, who made it, what's the health condition of that asset, how it's configured. Given the right security credentials, you could get live streaming data from the sensors on that asset and have all the necessary context to infer meaning and establish relationships to other data points. So it gives you a standard way to interact with an asset. OEMs can design this into the assets to create, or for legacy assets, integrators or factories can drop an asset administration shell on top of existing equipment to make it a full participant in your Industry 4.0 ecosystem. Now, if utilizing the collection of all those IEC standards is just a little too daunting right now, I offer an alternative minimum requirement. And in this case, don't do point-to-point integrations, right? Use an event-driven architecture. Your assets and your system should publish data to a single source of truth or a central hub where you can publish using a publish and subscribe messaging system. Some refer to this as a unified namespace. There's a rich market of vendors who provide brokers to implement this at various scales. MQT is one frequently used protocol in this architecture. Certainly you can use OPC-UA if you use the pub sub spec. And other protocols work well as here. So these are key things that you can do to help prepare for what's coming.
Thank you. So in this slide, I'm going to present a little bit about modernizing automation equipment and software, along with some best practices. Modernizing control systems certainly has numerous benefits, but there can be risk in doing that. And a proven way to reduce such risk and to really offer the best possible outcome for our customers, especially on large-scale projects, has been a phased approach. So considering the initial investment made in automation and control hardware and software, there are often options to ease into these modernization projects without causing a lot of stress or downtime or even excessive expense. So some of our key elements to this approach include developing a detailed scope of work, with project scheduling and identification of facility personnel that will partner with us. That's really important that we have somebody that is a champion of the project on site. Software conversions and factory acceptance testing with client SCADA, and a drawing package that includes network diagrams, electrical requirements, mechanical layouts. So some of the best practices that go along with this, over the last few years, we've taken on some rather large modernization projects. And we use the manufacturer's modernization tools often that allow for this phased approach to reduce risk, expense, and downtime. So this technique will also allow customers to gain some immediate benefit from modernization through this method. This slide that we're looking at here depicts a legacy system on the left, which includes a hot standby PLC system, actually a number of them, with a coaxial remote I/O network that supports around 100 remote I/O racks. So using modernization hardware and software tools, we converted the programs, validated the PLC applications using the client SCADA software. And by loading that on our own servers, we were able to test that. After acceptance testing, we installed the new hot standby CPUs, which you see on the right-hand side, which continue to service the existing remote I/O network, which, like I said, is over 100 racks. So in this instance, we were able to install and test 13 hot standby PLCs during a plant shutdown period of approximately 5 days. So considerable time savings using some of those conversion and modernization tools. So to sum it up, for us, a phased approach can be beneficial to making larger scale projects more manageable. We use software and hardware tools from the manufacturer to streamline this process. And you can't underestimate the importance of planning and the documentation that goes along with this type of project to ensure that your hardware and network requirements are going to meet the client's needs and result in a successful project. Thank you.
So as we look at implementing upgrading control, one of the things that we find the most successful for us is make sure that we follow a critical project development life cycle. And I'm going to echo some of the things that Mike just said there, in that we find that a good documentation package is the best place to start for the project. Too often we find that customers don't have good documentation for the new equipment or the existing systems that they have. So getting that documentation in place in a good drawing package, or even like an functional requirement specification or user requirement specification is the best place to start. But quickly after that, we put a lot of emphasis on building the infrastructure to support the future growth. Not all of those projects are beginning with the end in mind. So we really like to have that conversation with customers about where they want to go in the future as they kind of evolve in their digital transformation. That usually means getting their IT group involved and aligned early, whether it be data acquisition or additional visualization, or even if the scope of the project doesn't require it, they may want to maximize their current investments by setting a foundation for the future when it comes to data acquisition and tying those components together. And the final step for us is really making sure that we're reviewing the process along the way. And that's different for every customer, every project. Sometimes those are in a couple of steps, and for larger project, more extensive ones, more phased approach, similar to what Mike mentioned, that requires more touch points. So making sure that we're doing that through both the design process and through the development process whether that be getting alignment with screenshots or with simulations of the system, making sure that you both know where you're going so that the endpoint isn't a surprise to everyone, becomes an important step in the process.
That was great. Could each of you now please provide some insights about how you help customers prioritize based on their needs? Tyler, why don't you go ahead?
Yeah, thanks, Mark. This will dovetail well, I think, into some of the things that Matt and Mike were just talking about in terms of the phased approach. But, really where we start, and we go through this workshop process, the first question is really what problem or problems are you trying to solve? We see a lot of customers that latch on to, say, a technology, something that they saw, say, at a trade show or read about online, and then jump in feet first because it's exciting, it's new. And this can lead to some success, but it often results in many different point solutions across the manufacturing floor, silos of data, which you heard Randy talk about was a no-no earlier, or even multiple tools attempting to solve the same problem. Worst case, something can fail or just lose support from stakeholders altogether. So instead, what we recommend is really define the problem first through a methodical process, include stakeholders all across the value stream, and then develop a roadmap to success, kind of that phased approach. And so how we do this is what we refer to as a digital transformation workshop. This doesn't have to apply only to digital transformation, but that's kind of the focus here. And really what I'm referring to there is any kind of project that includes, say, a co-requisite change in culture, especially those that are involving many areas of the business, like planning, operations, quality, maintenance, et cetera, or especially if the project requires a bridging of that IT/OT boundary. So workshops that we do are typically 2 to 3 days, broken into 3 main phases: discovery, collaboration, and justification. The first day focuses on discovery. This is where we learn about the process, we walk the floor, we assess existing infrastructure, at all levels, network controls, et cetera. We look at digital systems, how data is being collected today, if it's manual, if there's automation involved. We interview stakeholders, everything from leaders to end users. And then once we've established the problem to solve or problems to solve through that discovery process, we move into a collaborative phase where we discuss the art of the possible. We do this through demos, through brainstorming sessions, looking at past solutions that have already been proven to solve these problems. And we really want to evaluate, say, needs versus wants. It's easy to get excited about doing a lot of things in this space. So we got to balance, short-term versus long-term goals, look at what are prerequisites, to help define that phased approach. And then we build that multi-phase roadmap. So then the third day, we get into more of a justification. This kind of further refines what we do in the second day. But we really want to define what success is going to look like in a way that's clearly understood and communicated, and make sure that that success results in value for the business. And then lastly, we want to debrief executive management on the results of the workshop and ensure that they weigh in on the next steps. On the left, there's a few overarching workshop expectations, making sure pre-work is done ahead of time so we can hit the ground running. Being face-to-face for the full time, we prefer to avoid virtual if at all possible for these. And we at least want to be on site during the discovery day. Participation is paramount. There's no wrong questions or points of view. We want everybody to be on the same team and rowing in one direction. And a big one is really anticipating change. These projects are going to involve change, whether it's all throughout the business or at least at certain levels. And that's just something to be prepared for. So next, I'll talk a little bit more about who should be involved. There's really no right answer on the number of people you include in a workshop. We found the best recipe is to have a core team of stakeholders that really know the business inside and out. They can dedicate the necessary time for the workshop, and ultimately they're the ones that are going to own and drive the resulting projects, as well as that associated change management I mentioned. Then we want to establish an extended team that includes, any other remaining key people within the business. And, we like to see representatives, as you kind of see there, from operations, maintenance, controls, engineering, planning, IT, or Matt, mentioned earlier, you want to include them early. That's definitely true. And if a customer has a designated continuous improvement leader, that's even better. It's not always clear who in the business is going to have interest or skin in the game in these types of projects. So by including a multidisciplinary team, customers often find value in unexpected areas, and that can lead to further buy-in and leverage for moving the project forward. Also, by engaging at all these different levels, even down to, say, operators in the workshop, you get a sense of ownership it's established early, and that goes a long way during implementation. So it's really about keeping a balance. Too many people involved can certainly stifle progress in the workshop, but a lack of key representation is definitely going to be a problem too, because you're going to have lost information or failure to get buy-in. All right, I'll pass the baton.
Thank you, Randy. No, I'm Tyler. Sorry. This topic, I think, is something that obviously is important to a number of us, and I'm going to just kind of stack on top of what everybody has already presented. I have similar information here, and for us, to start the process, we really need to understand what the clients have in place and try to determine their long-term goals for the process or the system, and move through the design phase with transparent communication is key to our success. As noted by these other gentlemen, discovering the customer's needs with feedback from all the stakeholders in a facility or at a plant is often the biggest challenge. You really need that champion who's going to help drive the project and bring in their team members to make it successful with the system integrator. For us, we do have a kind of infogram here that shows the process of discovery, of development of the scope, development of an estimate based on our years of collected historical data, the build, whether it's software, hardware, the testing and validation process, and then the closeout process, which includes training and documentation. So ultimately, our goal is to develop a written scope of work that captures the best possible outcome for our clients. And it all boils down to what does a successful project look like for you? What is the how do you measure that as being a success? And if you can get that, it's a better path and more clear the direction that you need to take. There's always going to be some surprises along the way, and we try to mitigate those as much as possible by thoroughly evaluating the existing operations versus that successful project outcome. So for us to sum it up, it really needs to be a written document that everybody agrees upon at the end of the day, and continuing to communicate and continuous process of feedback during the project to continue to keep the successful project outcome goal in mind. So thank you.
Well, the fun part about going third in a group of other good integrators is I get to try to say the same thing in a different way. I will also stack on top of some of the good things that these guys have already said. I will say from a project prioritization standpoint, planning is essential. And we found that in working with a lot of our customers, the most successful way and that they make their way through the digital transformation are the ones that commit to a long-term planning process. So they don't come in and say, okay, how do we do this one project, or how do we do these two projects that we have on our budget for this year? But they look at their business and where they see it going 2 or 3 years out, and they commit to planning towards that. And when we're involved, we find that a plant audit and just a review of what they have already is the best way to start. Is it manual? Is it already integrated? Do they have islands of automation out there? Do they have a strong infrastructure, network infrastructure? And then based on that, we typically sit down with them. We have a report that we review, and we go through a planning meeting to where we look at critical component risks, pain points after discussions with their operations team. And we look at understanding the goals that they have in mind. So some examples of that, sometimes it's just optimizing uptime or getting production gains without adding additional headcount or improving quality in a certain place. But recently we had someone say that we need this to be a more desirable place to work. They want apps that the young generation is willing to dive in and work on the plant floor with. So after that the discussion and that planning process, we go through a suggested project plan, whether it be a single project, a single year, a multi-year approach. But we find that's a good way to close a loop and really get buy-in from the customer in terms of what their goals are and how attainable they are and how those goals meet with the rest of their business goals beyond automation. And spoiler alert, but those goals change sometimes, right? So the important part of that is that we repeat that process either at the end of the first project or the first phase, or annually or quarterly, depending on what their path is. So with that, I'll kick it back to you, Mark.
Great, thanks so much. Could each of you please provide some examples and best practices related to important automation controls and technologies? Perhaps name a few technologies that will be particularly important for your customers in 2023 with some explanation of why. Randy, you want to go ahead?
Sure, thanks, Mark. I'll note that having an MES is a really important part of your digital transformation. That's not necessarily a new fancy technology in 2023, so I'm excluding it from my new technologies list. So make sure you have a good one, and then pay attention to the following three things that will accelerate you on your digital transformation journey. So if you embrace digital transformation to run your business better, you're likely going to have to do some sophisticated analyses. They'll likely be highly dimensional, lots of different inputs. Humans are usually pretty bad at this type of problem, but computers are actually quite good. Artificial intelligence, machine learning tools are readily available to help you make sense of all the data you're collecting. If you do deploy a machine learning model, one of the key things you need to do is keep it fresh. Take advantage of the fact that every day more data is available, and if you're using data to train your models, you can make your model better every day. So the training, testing, evaluating, deploying of these models can be automated. Usually that's called ML ops. That's the combination of machine learning and DevOps. That really helps take your machine learning level and keep it fresh and keep it getting better every day instead of fading as the process naturally varies. AI, ML, they're really fantastic technologies that already changed the world, but they require a massive amount of data to really do a good job training and to run predictive analytics. We talked earlier, you really can't just drop AI on top of traditional manufacturing systems. There's two key problems to overcome. One, the relationships between all those data points in those various information systems, that's usually not codified in a way that automation can learn from. And the second is, data is trapped in silos, and it's difficult to get the massive amounts of data out in a usable format. So towards solving those, to get the context, meaning, and relationships, one can use ontologies. Ontologies classify and explain data in data relationships in a formal way. So they allow us to link entities and understand maybe how a temperature sensor value relates to a product quality attribute and how that relates to another thing of interest. When these relationships and context are captured in an ontology, your automated information processing systems can be applied. And if you store these relationships in a graph database, you can efficiently learn new relationships to build off your ever-growing understanding of your operation. So to contrast that to a more familiar way, suppose you identify that a previously unknown relationship between two sensor values, and you want to change, so now you need to change a property in a relational database. It used to be single valued, now it needs to be multi-valued. That would require you to delete the entire column for that property, create an entirely new table, add a foreign key reference. It's a ton of work. It invalidates your existing indices. It's just hard and expensive to do, and so usually it's not done. To contrast that, if you learn a new relationship about two data points with a graph database, that would be insert a node in the database. That's a much easier way to persist that new relationship that you learned and take advantage of that going forward. So I'm not suggesting replacing your MES's, ERP historians. I'm suggesting you can add a graph database that stores relationships between your existing data stores. This lets your AI ML algorithm embed the context, enables you to discover new relationships, accelerate your learning. And if you use a graph query language as part of your query, that helps eliminate a lot of the performance problems of trying to pull out all that massive amounts of data multiple times for your AI ML systems. Okay. So we can't know everything in advance if we expect the business to continuously learn. One of the things that we need is all that data. We need that context. To get all that data, because you don't know ahead of time what data you need, one suggestion is grab it all. Utilizing things like a event-driven architecture as opposed to a point-to-point integration that can give you all that data. You publish it from your PLC. If you don't end up using it, it doesn't really matter. And the technologies enable you to move all that data without a huge load on the processor and on your network. And once you learn something new, you can push it back into that event-driven architecture or namespace so that others can take advantage of that as well, lowering the cost of your overall systems integrations and maintenance going forward. So if I summarize all that, get all the data, publish it to a central hub or unified namespace, capture the relationships you know today in an ontology, update that ontology when you learn a new relationship between data points, apply machine learning and ML ops to automate complex analyses and help discover the root cause of your nagging problems. So if you stack all these technologies together, you can make your better business decisions faster, accelerate your digital transformation, and give yourself the business agility you need to win in the market. So with that, I'd like to pass the baton. I think Mike is next.
Thank you, Randy. I think I could learn a few things from you there. Some of the new technologies in 2023 that George D. Hall is looking at and starting to implement include Git version control for PLC programming. For us, this is a pretty exciting new technology that leverages cloud-based, type solution that allows you to share development across, regional offices and allows developers to work on the same file at the same time, all while maintaining version control and traceability. Some of the advantages of Git include, the fact that it's a mature open source tool. It's been around since 2005, and it's the most widely used version control system in the world for software developers. It's just been a challenge for PLC companies to embrace that because there's not a lot of standardization across manufacturers. Git, is distributed. The files are stored locally and in a repository, so developers can work without network access. It's fast, and history is stored local on a user's device. It's secure. There's an algorithm that ensures that every edit is traceable. So that this is a tool that we're finding to be very valuable moving forward into 2023. Another interesting technology that we're exploring further is augmented reality. Having seen numerous demonstrations and applications for this technology, we're exploring how it can benefit our clients in training and maintenance and troubleshooting of machines and equipment. It's a technology that's designed to add a digital element over equipment using a tablet to give you a visual of the equipment inside, say, an enclosed enclosure that may or may not be accessible. And the data that's available to you there can help troubleshoot, provide machine health, any number of different types of data are available to you through that graphical type interface while on the plant floor. And then finally for us, software conversion applications. I mean, it continues to reduce our time and expense in a lot of modernization and upgrade applications. You know, most manufacturers are offering software conversion utilities to convert legacy platforms to newer systems. And some even offer cross conversions to convert from one manufacturer's PLC to another. Well, most of the applications we convert are legacy ladder logic, and we're moving to an IEC 1131 standard. There's 5 languages that are incorporated with that: instruction list, structured text, ladder logic, function block, and SFC. And one thing that we do find is the conversion tools are efficient and help expedite the conversion and modernization process, but they're not perfect, right? They capture 80 to 90% of the original code usually, but there are some functions that need to be rewritten in the new language. The conversion tools can also prevent a user from maybe taking advantage of some of the other languages. Example, we're converting ladder to ladder, but maybe there's some functions that would be better suited for structured text that would have to be, coded from scratch, basically. So these are some of the exciting technologies that we're exploring and utilizing. There's far too many to capture here, and in this forum, and between all the information that's been presented so far. I think the industry as a whole is kind of going through its own modernization. It's an exciting time. It's difficult to keep up with at times. It's constantly changing. But these types of events, I think, help people explore and understand what is new and what is coming out in the industry. So, thank you very much.
I think I'm going to keep piling on type of what Mike's saying. I think as system integrators, this is kind of the most exciting topic for us, and has been for a while. But even as Industry 4.0 is gaining traction, we personally felt that we had a lot of customers who were hesitant or dismissive of the potential from doing a lot of the things that are out there. But over the last couple of years, I think primarily due to the changing workforce and a younger generation of people coming in, we're finding what we find to be, well, I'm not going to call them new, but prevailing technologies, the stuff that have kind of risen to the top in terms of benefit for a lot of our customer base. And the top of that list is absolutely the advanced analytics, the AI, the machine learning capabilities. You see an adoption from OEMs and machine manufacturers and component manufacturers to make their stuff accessible to systems and to have more data embedded in them. There's still the challenge of getting that to a central kind of storage place, as Randy mentioned earlier. But the tools are there. The digital twin software applications are there to help you get more predictive information out of the systems. The next thing that I'll touch on is the mobile workforce. Again, we've grown up and had children grow up with tablets or devices in their hands, and we haven't seen as much of that adoption on the plant floor. And quite frankly, we found that a younger generation is coming in and expecting it. They expect app-based type of interfaces. They expect to be able to pull something up on a tablet and have the same sort of interaction, same sort of icons that they've grown up using. Why can't they get that information out of the system? And the last one is more robotics. Again, robots have been around for a long time, but as an example, we play more in the processing areas or the upfront, and we haven't seen as much of them there in the industries that we're in. But we find that a lot of customers are striving for efficiency gains. They're just struggling to find people in those areas. And that, one, the availability of robots to put into those places, and two, the need to find someone to do some of those jobs is greater than it has been before. And especially when you look at auto-guided vehicles or autonomous mobile robots and what those can do to traditional warehouse spaces or processing areas that are spread out at the front side of facilities. There's a lot of applications that people are really diving into, not because they want it, not because they want to go down this Industry 4.0 journey, but because they need to, and their workforce is demanding it. So, Mark, back to you.
Great, thanks all. The audience listening live can type questions for today's presenters in the Ask a Question box on the screen, and we'll get to as many questions as we can. Within a few days, the presentation will be available for on-demand viewing, along with the link to the quiz and for potential PDH credit. We'll post the archive on the Control Engineering website and send an email message with a link connecting directly to it and related resources after it's ready. And so now on to the questions. We have many coming in. We had many submit questions with their registration, and so we'll try to go on here as we can. One quick word up front, go ahead and submit your questions throughout the Q&A, and we'll get to them offline if we don't get to them online. So now just ask the presenters about edge computing. Any comments about how that's fitting in with automation controls and instrumentation?
Sure, that can be a very broad term and question. Edge is usually meant to counterpoint or contrast cloud. But as computing becomes more available, higher reliability, you don't have to do everything in the cloud. A lot of people in our space are scared of the cloud, but really these can work very well. And you can put computing devices closer and closer to your machines and your edge, and you can share the information between them. Data itself has something called gravity. The more data you have somewhere, send your processing to that instead of pushing all your data somewhere else. So edge is an important part of how you would do an overall processing and optimization and understanding of your operation. So super important part, lots of ways to do it. Big fan from my perspective. Others?
I think you summed it up rather well there, Randy. I mean, it is a big topic, right? It's easy to say edge, but what does that mean, across the board with different technologies and manufacturers?
Yeah, I think from our standpoint, we've seen people looking for edge solutions when they're not ready to maybe make an investment in a centralized distribution model. Kind of adding a couple of edge applications to get started and plan for the future is a good step down that path.
Great, thanks very much. Could we talk a little bit about AI and ML applications and where those are finding their way into automation and controls?
Oh,
Randy,
yeah.
maybe you want to start with that?
Yeah, absolutely. AI ML has a lot of examples in industry today, a lot of predictive maintenance applications that forecast remaining useful life of equipment. AI ML is great for that. Used often a lot of times in quality checks, certainly around visual inspections. It's a great tool for supply chain management to do your demand forecast accuracy, predict raw material prices, do inventory management, software performance improvements. Lots of examples of all of those types of things. I would caution you, if you have a hard problem, don't just say AI ML will solve all problems. You have to formulate the problem well. But it is a great one if you're having trouble thinking through all the higher dimensions, you just can't quite find what you're looking for, but you have the data available. Great application and tool used in that situation.
I recently sat in on a presentation for some a vision application that incorporated AI, and we're touting the fact that it's more powerful than standard AI or standard vision systems in that you don't have to teach the system as much as you would with a standard vision.
I guess my only comment here really is, there's, as Randy pointed out, there are a lot of applications for this. I think the most common applications are ones that are more repeatable, high dollar assets. There's lots of examples of those. It becomes increasingly difficult to apply AI/ML to individual one-off manufacturing problems. It certainly can be done, but I think as you heard earlier, the data isn't always there. It's kind of assumed, hey, we have all this data. Even when you have tons and tons of data, it still may not be the right ones required to apply to AI/ML. So back to defining the problem and really understanding it is key to make sure that you make good use of AI/ML.
Well said.
Yeah, I think I'm just going to second that comment, and that we found, if you have the right set of data, it's surprising how fast you can get something in terms of results back. But oftentimes, turning that into the right results that can be actionable is what takes the longest time in that process.
Great, thanks. Do you have advice about integration with existing PLC applications? Matt, maybe you want to start with that?
Sure, yeah. I will just, in our experience, the amount of documentation that you get with existing PLC applications can vary wildly. And your success for that project is very much tied to the amount of information or documentation that comes with it. So spending some time up front to understand what's there and what documentation needs to be added, and understanding that there might be a big leap in adding documentation if it doesn't exist. It's not as easy as just jumping in and making the integration. And two, making sure that you have time, especially if there isn't as much documentation, to extra time to commission those sort of projects, because as much as you think you've learned about it, it's easy to find gaps.
And the older the equipment, the harder it becomes, right?
That's right.
Good. Here's a question. What's the most common argument against implementing an MES system with a customer?
I can take a stab at that. I think, not knowing exactly where it's coming from, arguments against MES, or there are multiple ways of solving problems. And again, it sound like a broken record here, but defining, what the problems are. I think MES is, and MOM is still very alive and well today. I think it can be part of a digital transformation solution and very foundational to doing a lot of additional analytics. But there are a lot of times where a full-blown MES maybe is not required, and there are plenty of other tools out there that can just perform as data collection, visualization, and still getting to be able to solve problems. So back to having that agility of how you get there. A lot of MESs are kind of perceived as very monolithic and just a humongous undertaking. So I think going back to that phased approach, if you are doing an MES, don't try and do it all at once. Step through and find the most value first and then build out. But, and that's why having that long-term view is important in addition to short-term. But there are arguments, that would say there are other simpler, more agile tools than MES for certain applications.
Great. Any add-ons to that?
No, I think that's well said. I think that people are afraid of the beast that is MES when they start to talk about it, and that keeps them from getting into it.
Great. All right, so time for one more question. Let's see. How about comments on integrated motors and drives and how that's working with implementations, existing and new?
That's an area that we don't have any experience with, where you're talking about a motor that has an integrated drive on it.
Right. Yeah.
Yeah, that's something that we don't have any experience with. Typically, we keep those separate, drive cabinets where you can maintain environmental control.
I'd second that. Yeah, we really don't have any experience similar. Ours is either in an MCC or a motor control panel, and that's the typical orientation we see in the places we live.
All right.
Yeah,
so
speaking for EOSIS, I don't think we have, at least not from Randy and I's chairs, more in the digital transformation space. I don't have anything for you there.
all right. Well, an opportunity for growth. We'll work on that for a future webcast. All right, so thanks everyone for the great questions. Again, we'll try to get to as many of these unanswered questions offline as we can. And thanks again to our presenters for their insights and answers today. Tyler Graham, Director of Business Development, Digital Transformation, Randy Rausch, Director of Technology, Digital Transformation, both with EOSIS, Mike Howard, Vice President of System Integration with George T. Hall, and Matt Luger, with Northwind Technology Services. Thank you all for your expertise and presentations today. So the audience, as we continue here toward the end, I'd like to thank our sponsors, Kepware, PTC Technology, and Offices, MBT. And now that we're about done, we want your feedback. A short survey will pop up on the screen as soon as the webcast ends. Please take a few moments to complete it. We'll use the information to improve the webcasts. Again, if you're going to take the exam, go ahead and open that tab now because it'll close once the webcast ends. Finally, on behalf of Control Engineering and CFE Media and Technology, thank you for attending. This concludes our webcast. Thank you and goodbye.